I have an interesting problem from a number theory book by Charles Vanden, Eynden, and it's a mouthful, but it states that show that if m is a positive integer, then m is divisible by 2 to the k if and only if the positive integer formed by dropping all but the last 5 digits of m is also. Now, so I'll just write down some information that I happen to know about this number. You guys can verify it numerically if you want, but 2 to the 5th divide, and notice the exponent here is 5. 2 to the 5th divides the last 5 digits, which is 7, 1, 5, 2. Okay, and I'll use double arrows right here. That's if and only if it's intended to convey logical equivalence. If and only if 2 to the 5th divides the entire number. You can't have one without the other. Okay, and I'm just trying to copy down the original number here, so that'll be 4, 7, 7, 7, what do we have here, 152. Okay, so this is a concrete example of an M. Okay, so this would be our M as far as this goes. Okay, now the rest of this is just piecing this together, why it works. This is a concrete case. This is the more general case right here. Now you can see what I've done right here. I've essentially just broken M into its last k digits here. You can see you have a sub 0, the constant term, and then all the way out to k minus 1. That's definitely k numbers. You start at a sub 0 all the way up to k minus 1 is k values, and this is the number represented. See, they're talking about the positive number formed. The positive number formed, that's what this red part is right here, and I call it L for last. Okay, now this is, it's not too hard from here actually, because we can note, we're going to, by supposition, we'll assume that 2 to the k divides L on the first part here. Okay, and then right down here is the only part we really have to establish, and this part right here is simply true because 10 to the n is actually 2 times 5 to the n. So I'll write that down. 2 to the 5, I mean, excuse me, 2 raised to the k divides 10 raised to the n. Okay, and I just did it, just to keep the notation straight, I just did it for all k less than or equal to. If the exponent is less, it's going to divide quantities that have larger exponents, is all this is saying. See, because this is equal to, you can write it like this, just parenthetically 2 times 5, or we can write it like however you want, 2 to the 5th, excuse me, 2 to the n times 5 to the n, right? We don't really need the parentheses, do we? But I'll just do that. Okay, so 5 to the n. Okay, so that really is, that's all there is to this, really, for the most part. I mean, so by supposition, we're going to assume that L is divisible by 2 to the k, all right? And then we've showed that the first part is also divisible by 2 to the k. So there's some will also be divisible. You see, 2 to the k divides this. We just showed this by supposition. So this 2 to the k does divide m, okay? Now, this is an if and only if problem, so we have to assume the converse. So we have to prove the converse. So we're going to assume that 2 to the k divides m here, the entire number. Here, just remember, we assume that 2 to the k divided the number formed by the last k digits, okay? Here we're assuming 2 to the k divides m, okay? All right, and so, but if this is just true simply because if a constant divides a pair of numbers, it's going to divide their difference. That's all this says, like a linear combination. Okay, so this actually completes the proof, folks. It works in both directions. I'll write QED here, although some of you may not be that convinced. but I think we've demonstrated it here. You can verify that it works for this special case that I presented right up here. And let me know what you think. I tried to keep it kind of brief and didn't write down every one of the details, but I think that splitting M apart like this made it real clear that these constituent parts were divisible by 2 to the k under the appropriate conditions. Hope you enjoyed.